When it says 56 kilograms on your bathroom scales, what are you actually measuring? Well, if you said weight, like most people would, then you're sort of wrong. Kilograms are a measure of mass, but the scales actually measure the force of gravity on your mass. So they do actually measure weight, but this should be in units of force, newtons. Confused? Keep watching. This is a 1 kilogram bag of sugar. Grams and kilograms are units of mass. Mass is a measure of how much stuff is in something. This bag contains twice as much stuff. It has a mass of 2 kilograms. It would be wrong to say the bag weighed 1 kilogram or 2 kilograms, as weight is a force caused by gravity. To measure the weight, we need a spring balance or force meter. This is a force meter, or a Newton meter. It shows the weight of something hung from it. Let's add the bag of sugar. It shows the weight is almost 10 newtons. Can you remember the equation that links mass with weight? Remember F equals ma, where F is force in newtons, m is mass in kilograms, and a is acceleration in meters per second. We can rewrite this a little as W equals mg, where W is weight in newtons and g is acceleration due to gravity. On Earth, g equals 9.8 meters per second. So the weight of the 1 kilogram bag of sugar is 1 times 9.8, which equals 9.8 newtons, as the picture shows. Often in everyday life, we use the word weight, when in fact we mean mass. The bag of sugar has a mass of 1 kilogram, but a weight of 9.8 newtons. Now let's take this bag of sugar to the moon. The moon is much less massive than the Earth, and so has a lower gravity. On the moon, g is only 1.6 meters per second. See how the weight has dropped compared to when it was on Earth? But notice, we still have the same amount of sugar. There is still 1 kilogram of stuff. The weight has changed, but not the mass. Jupiter, the gas giant, has a g value of 25 meters per second. Can you work out what the force meter would show for the bag of sugar here, assuming there was a solid surface to stand on? The sugar now has a weight of 25 newtons. But don't forget, we still have 1 kilogram of sugar. That hasn't changed. Do you remember gravity? Watch this video. An object thrown away from the Earth will experience a force towards the Earth which slows it down, stops it, and the object accelerates back towards the Earth. This acceleration is due to the Earth's gravitational force and is written as a little g. It's also known as the gravitational field strength. To stop the apple falling, so to prevent the gravitational force pulling it towards the center of the Earth, a force is needed that is equal to this gravitational pull. Remember this? And on Earth, g equals 9.81 meters per second, or approximately 10 meters per second. Okay, back to mass and weight. Remember that mass is a measure of the amount of stuff in an object and gives a measure of how difficult it is to get moving or to stop it. It never changes. For example, my mass on Earth is 56 kilograms. On the moon, I would still have a mass of 56 kilograms. The acceleration due to the Earth's gravity is measured in meters per second, or it can be measured in newtons per kilogram, as it's a force exerted on a unit mass. So let's now use this lovely equation to find my weight. Weight is the force due to gravity, and that depends upon the masses of the two objects that are attracted. On Earth, my weight is mass times gravity, so roughly 56 kilograms times 10, which is 560 newtons. But what about on the Moon? The gravitational acceleration on the Moon is only 1.6 meters per second. I hope you got 89.6 newtons. So, you would feel very light on the Moon, and if you try to walk, each step would send you leaping away from the surface. See how gravitational field strength changes on the surface of different planets. This is because the planets have different sizes and masses. The largest planet, Jupiter, with the greatest mass, has the highest gravitational field strength. My weight on Jupiter, if there was a solid surface to stand on, would be 1,400 newtons, and bathroom scales, which are calibrated in kilograms, would show I had a mass of 143 kilograms. You would feel very heavy, yet your mass would still be 56 kilograms. Just your weight would be 2.5 times more than on Earth. Now for Newton's apple. An apple with a mass of 100 grams is held in your hand to stop it from falling to Earth. What force do I need to prevent it from starting to fall? Take the acceleration due to gravity to be 10 meters per second. Pause the video and work this out. So the force is mass m times g, or 0.1 kilograms times 10. So the force of gravity on an apple is about 1 newton. And it was the falling apple that gave Isaac Newton the idea in the first place. How about that? And just remember, our mass always stays the same, but our weight can change. Maybe we should all move to the Moon.